As an Ansys partner since 1984, we are highly committed to helping you design, simulate, and succeed.
Hello everyone. Today we'll be taking a look at an example of a hyperelastic model in Ansys Mechanical. We'll also be going through the process of creating a hyperelastic material model based on experimental test data. So this model comes from Workshop 5A in DRD's Nonlinear Structural Simulation course. It is a 2D axisymmetric problem, so you can imagine this 2D slice being revolved around the global y-axis to create the full 3D geometry that we're modeling here. You can see that this assembly is a mixture of rubber and steel parts. And the physics of the problem are that we want to resolve this initial interference, and then we also have an annular spring body here that's exerting a force in the inward radial direction. So we'll be solving this as a two-step analysis. So in that first step, we'll be resolving that initial interference that you see here. And then the second step, we'll be ramping on this 100-pound force load in the negative x direction, which is that inward radial direction to represent the spring. And what we're trying to do is make sure that we have a fluid seal between the steel and rubber bodies here so that no fluid or particles can get past that seal. So let's take a look at the results. So if I animate the total deformation plot, you can see in the first step that we're resolving that initial interference. And then in the second step, we're ramping on that force load. And then the main result of interest here is going to be the contact pressure in this area right here. So we can plot that using the contact tool. If I zoom in, you can see this is the contact pressure that's predicted by the simulation in PSI. Now I also want to show how to create the hyperelastic material model. So let's go into engineering data. You can see this material that we've created here that's called rubber. So the way that we defined this was that we first copy and pasted some experimental test data. You can add those to your material from the toolbox here under hyperelastic experimental data. So we've got uniaxial test data, biaxial test data, and shear test data. You can see those data sets there. And then we need to fit those to one of the hyperelastic models that are available in Ansys Mechanical. So we fit those to this Mooney-Rivlin 2 parameter. I can show the process if I go ahead and delete that, and then I'll go through the process of recreating it. So from the hyperelastic material models here in the toolbox, I'm going to double-click on this Mooney-Rivlin 2 parameter. And then you see that it also adds this curve fitting item here. So this is how we actually fit the material parameters to our test data. So we just right-click on curve fitting, solve curve fit, and then in this graph you get a graphical representation of the curve fit alongside the experimental data. So if I'm happy with the results of the curve fit, all I have to do is right-click on curve fitting again and copy calculated values to property, and that will populate the parameters of my Mooney-Rivlin hyperelastic material model. So to summarize, we took a look at a 2D axisymmetric hyperelastic example in Ansys Mechanical, and then we showed how to create and curve fit a hyperelastic material model based on experimental data. If you're interested in taking DRD's Nonlinear Structural Simulation course, or for more information in general, please click the link in the description below.
Contact us today to discuss your unique physics challenges and find the right Ansys tools for you.